Okay, I've skipped over number 7. It was just like 6, find the test statistics. So number 8 now, this one wants us to make a decision to either reject or fail to reject the null. Okay, so there are 2 ways of looking at this. So one of them, we're going to set up our null and alternative, and then we'll have a critical value. It's going to say CV. This is given from that level of significance, and then we'll be given a Z value. So if the critical value, or let me just say our Z value, our test statistic, if it falls over here in this area, this is what we call the rejection area, we will reject the null, reject HO. So if it falls over here, if it's in the rejection area or on this side, same thing. If it falls past that cutoff point from that critical value, we reject HO. If it falls in between or, outside of it, so if our critical value is here, then we fail to reject HO, which is the null. So when we're doing this hypothesis testing, it's kind of like court of law. Either you are guilty or you're not guilty. We never say innocent. So the same terminology, we say reject or fail to reject. And basically you want to know, does it fall in the rejection region or does it not fall in the rejection region? Now there's 2 ways you do it when they talk about the p-value. So they give you a level of significance. It'll be like 1%, 5%, whatever you get. So let's say that this area, and they're giving it to us, is 1%, 0.01. Whenever you do your Z value, if p-value, which is the area to the left of Z, if p-value is less than, which is, and if it just means it falls in this rejection area, because if this is 1% and then your line is here, it's definitely going to be smaller than 1%. So if p-value is less than, let's say alpha, so that's what we really call it, alpha, then we reject HO, reject the null, and then if p-value is greater than alpha, you fail to reject. So that's on the negative side. I guess I should be looking at the absolute value of those numbers. I want to think about it. Yeah, absolute value of those would be a better description. So if you just look at the numerical value, if it's greater than, you fail to reject. If it's less than, you reject. Okay, but you'll see it as we set up everything. Okay, so this is kind of an idea of what we're doing and where we're going. So in this problem, automobile manufacturer has given the van a 34.5 MPG rating. Okay, so our mean is 34.5, sorry, 34.5 MPG. It says it is believed that the van is incorrect. Okay, so it just says incorrect. So my null and alternative is my mean is not equal to 34.5. Null is the mean is equal to 34.5. Okay, so we have our null and alternative set up, and now we have testing 200, so that is our sample size. N is 200. We have found the mean, the sample mean, to be 34.8. And we want to assume that the population variance is known to be 3.61. So sigma squared is 3.61, which we need to find standard deviation, so we got to take the square root of that. So sigma is equal to, and let me find that before I use the wrong number, Got to be careful. Sometimes they'll throw different values in there. So square root 3.61. You get 1.9. So this is the value we're actually going to use. And then we have to use our level of significance. So this is my alpha value, 1%. So level of significance, alpha is equal to 0.01. So we need to first find this value, and then we'll compare our test statistic to it. Now, since this is a two-sided test, we're going to have this number going to be on both sides. Okay. So 1% on the upper, 1% on the lower. We're going to use the table to figure this out. I think we can go to the miscellaneous. Nope. Critical value. Let me make this bigger. Having a hard time seeing everything. Tables. And then non-parametric. That's not the one. Okay. Z-table critical. We want 1%. Here's the alpha 1%. And we want that in two tails. So negative and positive 2.575. Okay. So I'm going to write that on our bell curve. Negative 2.575 and positive 2.575. So this area here is the rejection region. What is the area to the left? Let's go back and just show you that from the table, standard normal table. Let's just go to the negative side. Negative 2.575. So the area is that it's about half of that one. So that's just 0.005. So half a percent. And it splits it up into two tails. So that's what they're giving us whenever you have two-sided. Now we need to do our actual test statistic and then compare those two numbers. So doing the test statistic, sample mean 34.8 minus 34.5 divided by standard deviation of 1.9 divided by the square root of 200. Compute this. Open parentheses, we'll do the top, 34.8 minus 34.5, close parentheses, divided by, open parentheses, 1.9, divided by second square root of 200, and close twice. Okay, so our actual value is 2.23. So 2.23 is actually going to be in between or to the left, smaller than 2.5. 2.23 will be here. So this is my, so this did not fall in the rejection region. Here we would reject, here we failed to reject. So if you actually looked at this value, it would be the p-value, and you would have to double it because you got two-sided. Okay, you have to do the negative as well. I have to think negative 2.23. And you'll find the area to the right is the same as the area to the left of this negative, and double it. That will give you your p-value. And we would see that our p-value is going to be greater than, let's actually show you. It's easier to see it. Okay, so if I go to the table and standard normal, I'm going to go to the negative side, easier to read that one, 2.23. 2.23. Okay, 0.0129. So that's this area here. You can already see that this 1% is bigger than 0.5%. And when you double it, you have 8, area 1, 5, 2, 0. So this will be the p-value. You can see that the p-value is greater than alpha. So we would fail to reject. Same thing that this line is on, not in the rejection region, we fail to reject. They both do the same thing, they just kind of look at it in different instances. So when concluding this test, we would fail to reject the null. And the null was stating that the gas knowledge is equal to. So what that means is that the little bit of difference that we're seeing, which is 0.3 miles, is not big enough to say that it's not equal to that, because it could be.